Hello, right, so today we are going to be talking about speed, distance and time. This is a really simple one to get us kicked off. I know you've probably done this further down the school, so this should come really easy to you, and it's going to give us our first chance to look at things like units, rearranging equations, and solving using our calculator with prefixes. So, a couple of key definitions to start with. Distance, how far something has travelled. Time, how long it took to do that travelling. Okay, and speed is the rate of change of distance. Okay, now that's a key definition there that you're going to have to know, so definitely get that written down somewhere and start memorising it. The rate of change of distance, so how quickly the distance you've travelled changes. So that's why when we look at how average speed can be calculated, average speed is the total distance travelled divided by the total time it took. Okay, and so you'll see from our equation here, if you then write that in using what we're going to term as the physics way to write it, we've got speed is distance over time, as you've seen probably down the school. Now, when we're rearranging this, you are more than welcome to continue using the triangle that you may have seen elsewhere in maths, okay, to help you rearrange that. When you've got speed, distance, time, and if you are wanting to work out speed, then you cover that up, and what you're left with is distance divided by time, okay, or you cover up time and you'd be left with distance divided by speed. That's totally fine to get you used to it, not a problem at all, okay. What you need to remember as well, though, is that we have units for each of these quantities, okay? Now, a number without a unit means nothing to us, okay? Everything has to have its correct unit there for us to know what we're dealing with. Because if I said to you, oh, the car travels 500, the car travels 500 what? 500 meters? 500 miles? It doesn't really make sense. Without a unit attached, we don't actually know what the quantity is that's being described. Okay. Now, average speed is basically over the total distance. Okay, but if you think about a journey that you have, so think about something nice and simple like the journey to the shops. You get in the car starting from 0, and it's going to speed up and slow down depending on the different speed limits of the roads that it's on. But if we take the total distance between start and finish and divide it by the total time it took to get there, we'd get a number for the average speed that doesn't actually describe the speed the car was going at the whole way, because the car would have had to speed up and slow down depending on roundabouts, traffic lights, speed limits, all of those kind of things. And because of that, the average speed is only good for as an average, right? We have another type of speed that we look at called the instantaneous speed, okay? And the equation is the same, but the instantaneous speed is the speed at any one point. In a journey. Okay, and we use the same equation. Speed is distance divided by time, but it would be a much smaller distance in order for us to get an accurate reading. Okay, so for example, you could capture a car at the middle of the IBM road, and if you work out the speed it's going at the moment it passes you, it's probably up at 70 miles an hour, and that's probably an accurate speed for it at that distance. But if you take its entire average speed from the start of the IBM road all the way to the end of the IBM road, it wouldn't be 70, because it has to speed up once it comes off a roundabout and then slow down as it's going into a 30 mile an hour. So just using a road that's between a roundabout and a 30 mile an hour but goes up to 70 as an example, we can take the instantaneous speed as 70 at multiple points through that, as long as you're sticking to the speed limit as you should. But at the start and finish of that section of road, the car's speed would be different meaning that our instantaneous speed at any point is more accurate than the average speed that we're taking. Okay. The units for that, same symbols, same equation, just with a smaller distance, so the units would be the same as what we have there. Okay. Now, key points I would like to note with units is that when we're doing an equation that involves time, we always convert the time into seconds. Okay, so it's really important that you have to remember there are 60 seconds in a minute, 60 minutes in an hour, because you'll need to do conversions to work out how long things are taken. Okay, we always use our distance in meters, so if the question gives you it in kilometers, you have to convert it to meters so that we can do this calculation correctly. Now, with that in mind, we need to talk over these different prefixes that we have. Okay, so you're really only going to be dealing with, into this week's work, you're going to be dealing with kilo, right? But a kilometer, okay, is 1,000 meters, okay, which means that 1 times 10 to the 3 meters is 1,000 meters using scientific notation. Okay, so 1 kilometer, I'm going to do a wee bit doodling here. So 1 kilometer is equal to 1 times 10 to the 3 meters. And if you put 1 times 10 to the 3 in your calculator using the little button down the bottom that says times 10x, or it might say exp depending on what calculator you've got, and put 1 and then that button and then 3, okay, what it'll do is it'll come out with 1,000 meters. Okay, so 1 kilometer is 1,000 meters. Now that's the same for any one of these prefixes, only you use the different scientific notation that goes with it. So, for example, a millimeter is smaller than a meter. Okay, so that's why we have the minus here. And in that case, you would be doing into your calculator 1 times 10x button. That's terrible writing there, hang on a minute. Times 10x. And then minus 3 in your calculator in order to get that one out. Okay? And that's how we deal with the scientific notation. So I've got a few examples here, and yep, the first one is 1 millimeter. So 1 millimeter is 1 times 10 to the minus 3, okay, meters, which is going to come out as 0.001 meters. 1, 2, 3. Okay. If we were to convert 12 kilometers into meters, well, that would be 12 times 10 to the 3, because kilo is times 10 to the 3 meters, which is going to be 12,000 meters. 3.2 kilometers is going to be 3.2 times 10 to the power of 3 meters, which is going to come out as 3,200 meters. Okay, and 0.4 millimeters would be 0.4 times 10 to the minus 3 meters, which will equal 0.0004 meters. Now, this last column here on the right hand side is what these numbers are, but you don't need to know that. You can just put this column into the calculator. Okay, you don't need to convert it into all the numbers with all the zeros. That's what scientific notation is there for. We allow it to put it in the calculator, and it makes our life easier. Okay, so what I have now is I have a couple of worked examples to show you what you're going to be doing, and then I have a worksheet that you'll be able to work through. So, Usain Bolt ran a 100 meter in a record time of 9.58 seconds. What would his average speed be throughout the race? Now, there is a very, very specific way that I would like you all to be writing down these calculations, okay? And I'm going to work through this because this is key in how we're going to be looking at solving these for the entire time you do physics, okay? And it's very simple. Step 1, you write down what you know. So from our question, we know that Usain Bolt ran a distance of 100 meters in a time of 9.58 seconds, and then it says calculate his average speed. So that's us written down what we know. Our next step is we are going to write down our equation, okay, which we've just looked at up there. Speed is equal to distance divided by time. Our next step is we take the numbers over here and put them in where they go. So d is 100 meters, so you're going to put s equals 100, and time was 9.58. So you, I hope I could write it right. So you divide that by 9.58, and then finally you're going to write down your answer. You're going to use a calculator to get it right. It's really important that you're using a calculator because you don't need to do any mental maths for physics. It's helpful to be able to, but you don't need to. So it comes out as 10.2, and then it's speed, so it's measured in meters per second. And then we double underline our final answer. Okay? Now, as I said, he ran it in a record time of 9.58 seconds, which means he has an average speed of his 100 meter going at 10.2 meters per second. But that's not the speed he was going at throughout the whole race, because he has to start from 0 and speed up. So he's actually a lot more impressive because he can run faster than that. Okay, and if we have a car that travels 2.3 kilometers in a time of 1 minute and 55 seconds, so here's that conversion I was telling you about, where you have to convert between the kilometers to meters and the time into seconds. So step 1, we write down what we know. Well, we know the distance is 2.3 kilometers, which I'm going to write as 2.3 times 10 to the 3 meters. And our time, which is 1 minute 55 seconds. Okay, well, 1 minute is 60 seconds plus 55 seconds. It's going to be 115 seconds. Okay, and we're to work out the average speed. So speed is equal to distance divided by time. So it's going to be equal to 2.3 times 10 to the 3 divided by 115. Now, as I said, you can just put this into the calculator exactly like that using the times 10 to the 3 button. Okay, so you don't need to convert it into all its numbers with zeros. That's going to come out at 20 meters per second. Okay, now I have one more worked example for you. So our final worked example, we're going to be looking at a motorbike which is travelling at a speed of 13 meters per second for 45 seconds. How far does he travel? So step 1, we are going to write down what we know. And so in this case, we know that the speed is 13 meters per second. The time is 45 seconds. Now to work out the distance. So writing down our equation is speed equals distance divided by time. We're going to put our numbers in, so we get 13 is equal to distance divided by 45. Now that doesn't quite work for us because we need distance on its own. Okay, so what you can do to this to correct it and get it the right way around is if you multiply both sides by 45, or if you change this up to the other side and it's divided on this side, it becomes multiply on the other. So it'll become 13 times 45 is equal to the distance. So we'll be able to then write out what our distance is in meters, which is 585 meters. Okay, now I hope that's been helpful for you, dealing with speed, distance and time, and best of luck when you're doing these calculations.